In-class activity 4D, modeling the vibration of a cell phone continued. 1, summarize the process you used in-class activity 4C to draw the graph of R2 of T by hand. Let me just scroll that down a bit. All right. Well, we could answer this by saying first, let's see. We had the graph of R2 of T, which is 0.2 times the sine, 942.5 T, and this should be a sub 1. So let me erase that here and put a 1 there. So we had that. Okay, so we already knew the amplitude and the period. Now, to find the shift, the horizontal shift, we need to factor out 924.5 out arguments. Or the argument of the sine function. So this would give, let's write this, 0.2 times the sine, and then we factor out the 924.5, and then inside the second set of parentheses, we have T minus 0.0006. So the effective horizontal shift was 0.00006 to the right. Let me say that one more time. 0.0006 to the right. There we go. Just scroll that down. Let's make some more room here. And then we're going to find what we call the quarter points, or where the graph crosses the axis, the horizontal axis. So we could call that okay, now it seems to be working. Let's see. Find the quarter points, and then we could state that says where one period starts 0.0006, comma 0, and ends. So it would be 0.0067 plus 0.0006, comma 0. So that's just the period length plus the shift. The middle point should be at half the period plus the shift. So that would be 0.0033 plus 0.0006, 0. And then we'd have a maximum value at 1/4 the period plus the shift. So we could state that as 0.0017 plus 0.0006, comma 0.2. And then the minimum value is going to be at 3/4 of the period plus the shift. So 0.005 plus 0.0006, comma, negative 0.2. All right. Objectives for the activity. You will understand how to recognize the horizontal shift of the sine function, and you will be able to determine the amount of horizontal shift present in a sine function. Okay. Recall the model from the previous activity. For a motor that is spinning at 150 revolutions per second, the force that a cell phone exerts on a person when it vibrates is given by the equation R of t is equal to 0.2 sine of 942.5 t plus phi, where R of t is the force of the vibration, phi is the initial angle of the counterweight when the motor begins to spin in radians, and t is the time since the phone started vibrating in seconds. 2. Suppose that the last time the phone in the previous question vibrated, the counterweight stopped at an angle equal to pi over 4. Part A, let R sub 3 be the equation for the force when the phone begins to vibrate again. Without doing any calculations, predict how the graph of R3 will be shifted in relation to R1. So we could say the graph should be shifted to the left. Part B. Let's write the equation for the force R3 and graph it on the following set of axes. Okay, the graph of R1 is shown. So it says write the equation. So let me write this as R sub 3 of t is equal to 0.2 times sine of 924.5 t plus pi over 4. It's going to be equal to 0.2 sine 924.5 t plus 0.785 over 942.5, 942. Close the parentheses. So that would be equal to, let me make some more room, 0.2 times the sine of 942.5 t plus 0.0008. We graph this. Let me do this in a different color. I'll just use blue here. And marking the intercepts. And the amplitude will be the same. So just going to draw these. All right, let's go to part C. Part C, it says, describe in your own words how R3 is shifted in relation to R1 and the value of the shift. So let's see. The graph R, the 3, there we go, let me make a better 3 than that. R3 is shifted to the left. R1, and that's by 0.0008 units. Part D, what would you expect the equation would be for an initial angle of the counterweight stopped at an angle equal to negative pi over 4? Well, we could write R4 of T is equal to 0.2 times sine of 942.5 T minus pi over 4, which is 0.2 times the sine 942.5 parenthesis T minus 0.785 over 942.5. Close both sets of parentheses, and then we get 0.2 times the sine 942.5 T minus 0.0008. Part E. What would you expect the equation to be for an initial angle of the counterweight stopped at an angle equal to pi over 3? So let's write that 0.2 times the sine of 942.5 T plus pi over 3 is equal to 0.2 sine 942.5 parenthesis T plus 1.05 over 942.5 parenthesis equals 0.2 times the sine of 942.5 parenthesis T plus 0.0011. Close both sets of parentheses. And that is the end of this video. Thank you.